Hope I am audible. So we start from what we saw as last session. So I think so. Valid triangle number. We solved. I think we solved this problem. We'll just check it out. So I think we didn't solve this. No, I think we didn't solve this one. Yeah. So just solve the sort colors, and then we try to move on to the next. We return to the triangle numbers. I guess we solve these three, and then trapping rainwater. No, this one also we didn't solve. Okay, so we just solve sort. So okay, so first we try to solve move zeros. It's easy problem. Try to solve it, but I don't have an idea. So so they are given an integer array. So we need to move all zeros to the end of it while maintaining the relative order of the non-zero numbers. So if it's zero, we need to move that to the end of an array, right? Okay. So here the problem is, so we cannot able to extend the array, right? So we need to like rearrange these elements. Okay, rather we need to create a new space. So that's not possible. So this will be the problem here. I guess we try to solve this in a two-pointer solution. So, like, I guess we can solve like this. Let's say so 0, 1, 0, 12 by just like uh, now. Let's say this will be R, right? Then this will be the L pointer. Okay, we can just swap these two. So now the value will be here will be 0 is there, and then here 12 is there. Then we just move the L right, and then R right. If R is 0, we just move the R right. Right. Okay. So and then check. No. And then just move the L right. And then check if it's swap. I guess this will work. Uh, let's see. So just we write down the condition for clear. Uh, like we just need to iterate L, right? So till when we need to stop this loop, that means while L less than R. So we just iterate over and over. Okay. If L is equal to 0 means what we need to do is R not equal to 0. Right. Then we need to swap means array of L equal to array of R like this. Okay, so uh, and then what we need to do is L plus R is equal to 1, then R minus R is equal to 1. Okay. And then uh, if L not is equal to 0 means we just need to iterate the L by instead. Okay, so just try it out. I don't know whether it will work or not. So I think there may come issues on the test case if they had some tricky test case there. Let's say uh, we need a L and R point, right? So we set L is equal to 0 and R is equal to the length of then this while less than R means just coordinated as if L is equal to 0 R not is equal to 0 means just sorry, just swap sums of L comma sums of equal to yeah. Then we just need to move both the pointers. Then L L not is equal to 0 means just move L. Yeah, so I think that's just return what happened. Return what we need to return is the numbers. Okay. So we got some. Oh, okay. I just missed out something. So these two are not get spent, right? So that's one problem. And then we need to be it's in the sorted order. So this Can we do like this? So we can see. Uh, let's see. Just move this far. It's like bubbles are. So I just figure out. So the sum itself, the problem itself gives uh, like in an order, right? So here, if we see, if we observe it carefully, so here one is there, and then the greatest to one, but less than 12 is there. Three is there. 12, 3 is there, and then 12, the greatest is at the last. So the ultimate goal is not to change these numbers. So we just need to move zeros to the last, but without swapping just like as we do lastly. So how can we do this right? Uh, right. So what they are doing is L pointer is the pointer of non-zeros to identify whether the zero is there or not. So it will stop if there is zero. The R keep moving. The R will be move over and over. So like we just say uh, like if uh, what they are doing is so the L is at 0th point and then R is at also the zero portion only. So if R not equal to zero means we need to do some conditions. Here R is zero. So we just move R to the next one, right? So if then again the condition if R is zero or not, yes zero. Just we need to swap these two. So now what will happen is one will be at here and then zero will be at here, right? Zero, three, and two. Yeah. Now again, so let's say if R will be iterator and then L will also be iterator. So here, so here R is zero. So just iterate R. So here R is not zero, right? So we just swap these two. So here 3 will be there. Here 0 will be there. Right. And then next, just iterate the L, then R, then swap again. That's it. So that's how we need to solve this. So here, what are the conditions? So like if R not equal to zero means we just need to swap L comma R is equal to R comma L, right? And then uh, okay, so this will be a condition, right? So if it's not, so if R is zero means we just move R only. So we just use the for looping. So and then just solve. So L equal to zero, and then for I in like for R in range of 10, if the nums of R not equal to 0 means we just need to swap nums of L, uh, nums of R is equal to nums of R, comma nums of L. And then we just move L, right? So just return nums. Yeah, this will work. Not the nums. So now we just move on to the next problem. We will be sort colors. We try to solve these sort colors. So I'll maybe solve this. So they are given an array of object so. They show that objects are the same for adjacent. The colors in the order red, blue, white, and blue. We'll use the indices 0, 1, 2 to represent the red color, white, and blue. Okay, so in this, the zero number represents the red color, and why one will be white and two will be blue. We just need to order that. So we just sort this problem. We just use the sorting algorithm. But this we can just use the sort because of the complexity, and then so will be a problem. Then we just need to move all. So how can we do this? So here, if we see, it's like this is, I think this is the Dutch flag problem. Means, so it has three colors, right? So the same one, red, white, and blue. This is the Dutch flag problem. So here, we just use the three pointer thing, like just like we just use for the threesome, right? Threesome problem. So here, I try to move this one, and then just so you just need to uh, point a pointer here, and then point a pointer at the last one, and then point a pointer at the middle one. Let's say one, two, three, four, five, six. 6 by 2 is 3, right? 1, 2, 3. So here will be the midpoint. So I call it M, right? So here's the thing. So if the low has greater than 1, means we just need to it's greater than 1, right? So we just need to move this 2. Just need to swap 2, right? I guess so. Oh, no, 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 no. No, I think we just need to. Uh, can we do that? Yeah, so let's say. So here, let's say if we swap L and R, we had a problem like this. Let's say so here. So if we swap, here will be 0 and then here will be 2. It's arranged, right? So, but if we move R and we move L, so what will happen is we just try, we just move the L pointer here, then we just move the R pointer here. Now, so L is has 0, so that's not a problem for us. And then we just see the mid pointer. So it's 2, right? So we just try to swap the mid pointer and the R pointer. So now what will happen is, so here 1 will be there, and then 2 goes right there. So and then 2 goes right there, and then M we swap, we move M here, and then we just move R here, right? So R will be right there. So you don't just need to do any changes because it's already sorted. So I guess this will be the answer. So we just try to write the condition and then try to solve for the next test case. If that is right, better we'll go with that. So what are the test cases? So if L is equal to L is greater than 0 means Yeah, I guess we just doing a wrong thing. So I think I already saw the problem. I just saw the solution. Okay, we just here what we are doing is so we see the midpointer and try to move this one. But how can solve this? Okay, we just pause what we had done. So we try to solve in our own way without that solution. Here, what we done is, so if L is greater than 2, so it's equal to 2 means what we had done is, so we just shift uh, L comma R is equal to R comma L, right? And then we move L plus R is equal to 1, and then we move R minus R is equal to 1, right? And then what we had to do next is if uh, M is equal to just try to solve the one equation. Like if M is equal to 1 means you just iterate M. Okay, so if M is equal to 2 means you just swap M and then R and then iterate. Right. Just implement this. Try to see.